Well, hello to L. We're going to talk about applications of similar triangles. So today's learning goal is I can successfully sketch a real-world situation that involves similar triangles when given information and determine the value of an unknown. So here we go. I'm going to go through three kind of real-world situations where you can use similar triangles to find side lengths or heights for the most part. So the first one says Michael is 6 feet tall and is standing outside next to his younger sister. Okay, so we've got Michael, who's 6 feet tall. And this is what you should do when you're given a diagram. Just piece by piece, draw some diagrams. So he's standing outside next to his little sister. He notices that he can see both of their shadows and decides to measure each shadow. His shadow, down here, is 8 feet long. And the shadow of his little sister is 5 feet long. And we want to figure out how tall Michael's little sister is. So this line here I drew is Michael's little sister, so I'm going to put a T for how tall she is. Now the first thing I'm going to do is I drew the shadow on the ground and them standing up. So now I'm just going to connect them and make triangles. Now I'm going to tell you why these are similar triangles. They're similar triangles because they're both standing upright. So this is a right angle if they're standing upright down there. And a shadow is formed by the angle to the sun. So this in here is the angle to the sun, and if they're standing very close to each other, the angle up to the sun is exactly the same. And if you have two angles in a triangle the same, that makes the third one automatically the same because all of them have to add to 180 degrees. So we've got two similar triangles here, and we can use that to find out this T. Now, first of all, we don't need to know anything about this side. We don't have to use it at all. So I'm just going to put 6 and 8 on the top of my ratios. And 6 is across from the double mark, which means that it goes with the T. And for this one, we can just put height goes together and shadows go together too. So 8 over 5. Now we're going to use our cross multiplying to do this. So remember with cross multiplying, oh, that was weird. Let's pull this back over. With our cross multiplying, we're going to multiply and then divide. So that is very strange. Okay, so we got T equals 6 times 5, that's not a 5, 6 times 5 divided by 8. Let's pull out my calculator and go 6 times 5 divided by 8. 3.75. 3.75. So that means that Michael's little sister is 3.75 feet tall. And we should put a concluding statement. Therefore, she is 3.74 feet tall. Okay, now here's the next one. Here's another shadow lamp. It says, when you are 15 meters away from a street lamp, you get a friend to measure your shadow. So here's a street lamp, and you're 15 meters away from the street lamp. So this distance in here is 15 meters. The shadow is 3.3 meters in length. So we've got a 3.3 meter length there. And it tells us that you are 1.8 meters tall. So this is us. And we want to find out how tall the street lamp is. Now, at first this may not look like we have two triangles, but I'm going to show you that we really do. So here's the street light. So I'm just going to call it S for street light. We actually have two triangles. We have this little tiny one here that I'm going to draw outside here. That little triangle is 1.8 down here and 3.3 down here. And then we have a bigger triangle that is this whole big triangle where the side thing here is S, and then down here along this side it's the whole side. So we have to add 15 and 3.3, and that's going to give us 18.3. So this is 18.3 on the bottom. Now, same as before, they're both standing upright. So this is a right angle, so we know that that's similar. And this angle down here is actually exactly the same in both triangles because it's coming from the street light. And once again, this up here is going to be the same in both of them because if you got two the same, they have to all three be the same because triangles only have 180 degrees. So Let's set this up. Across from the dot, we have the X and the 1.8, and across from the double mark, we have the 18.3 and the 3.3. Now let's cross multiply. So we're going to have S equals, we're going to cross multiply this way and then divide by this one. So 1.8 times 18.3 divided by 3.3. Pull out the calculator. And we've got 1.8 times 18.3 divided by 3.3. And that's going to be 9.98, basically 10. S equals 10.0 meters tall. We should have a full concluding statement, but I'm not going to do that. We're going to move on to the last example. And this says, if you place a mirror 16 meters from a tree, so I've got this all drawn out already. So here's our meter. It says it's 16 meters from a tree. So this distance here must be the 16 meters. And then you back up until you can see the top of the tree in the mirror. And you need to back up for 3.4 meters. Now we measure your eyes and find that they're 1.6 meters above the ground. And we want to figure out how tall the tree is. So this is the height we're trying to find, how tall the tree is. Now, are these two triangles similar? Well, once again, you're both standing upright. So there's one angle that's the same. And you have to know a little bit about how light bounces off a mirror. When light comes down and bounces off a mirror so that you can actually see what's in the mirror, it means that this angle and this angle are exactly the same. And again, once you have two angles the same, then the third one is automatically the same. So we're going to do this up here. We'll set this up in the big triangle, and again, we don't need this side. Usually there's going to be a side length that we don't need to use that information for, that we'll only have two things to set up here. And this big triangle has a T and a 16. Now the little triangle, the T is across from the double mark, and across from the double mark is the 1.6. And then this little circle is across from the 16, and this little circle is across from the 3.4. So we get those set up. Now we're going to cross multiply. T is going to equal 16 times 1.6, and then we divide by that 3.4. So pull out the calculator, and we have 16 times 1.6 equals divided by 3.4. And that looks like 7.5 meters. So we can give our concluding statement that says, therefore, the tree is 7.5 meters tall. And we're done. And you now have a worksheet to do.